Good morning, everyone. Today is April Fool's Day, so April 1st. It is Thursday. Be sure to tell Coach Gaither happy birthday for me. If I was there, we would be celebrating. I wish I was there. So, since I'm not there, this is class. This is basically me saying, okay, I need you guys to do this and learn this. You have to do them. You cannot just be like, oh, she's not here, I'm not going to do it. Nope, I'm checking. Okay, so just like I check on my virtual kids, we are doing this work every day. So make sure that you are doing the warm-ups just like I ask and the actual lessons just like I ask. Thank you for those of you who did submit your warm-up questions. I got almost everybody's from second period. Fifth period, I got to pick that up. Okay. All right. So today's STAR questions, we will go over answers for yesterday's STAR questions soon, but not today. Okay. So let's move on to our 4 STAR questions. So we have this. It says, oh, by the way, sorry guys. If you are face-to-face, you should have this printed out for you. It is today's 4 questions for the warm-up and yesterday's 4 questions for the warm-up. You're not turning this paper in. I just wanted to give it to you so that you could kind of write on it and doodle on it however you need to answer these questions. Okay, so you're still emailing me the letter answer for each question. So you're going to say number 1 is F, G, H, or J. Number 2, F, G, H, or J. Number 3, F, G, H, or J. Number 4, however, is one of those bubble questions. So technically, you're going to say number 4 is this number because that's the answer. So you're just going to put number 4. The answer is blah, blah, blah. I don't know what number it is. I'm going to get to that in a little bit. Okay. All right, so let's go work on these questions. The first question says, which inequality is equivalent to 7x minus 2y is greater than 8? So when I see this stuff, and I don't know if my pen is going to work on top of the picture. Oh, it does this time. Good. Okay, so it says 7x is, or I guess I didn't really need to write that since it literally says that. Okay, so what I'm going to write though is the fact that this is written in a certain form that I recognize. It is written in ax plus by equals c, where 7 is a, -2 is b, and 8 is c. So I see these things are written in y equals mx plus b, where we know the slope and the y-intercept. We are able to find the y-intercept and the slope from standard form. So let's go find that and see which one of these has the same slope and y-intercept as this equation up here. So if I were finding the slope for standard form, it is a -a over b, which means we have a -7 over -2. Just like this. Now we know that 2 negatives put together will make a positive. So this is the slope that we are looking for. Okay, so we can automatically eliminate J and G because we found the correct slope. Next, we can find the correct y-intercept, which is going to be this number, and we will get our answer. We don't even have to care about the inequality symbol because we'll have an answer. We don't even need it. All right, so the only thing I'm going to tell you is that the y-intercept is found by C over B. So you will need to calculate C over B, and you will find your answer for number 1. Let's move on to, actually, clear that. Let's move on to number 2. I think this is in your way a little bit. Okay, so number 2 is mostly a reading problem. I'm going to read it out loud to you, and I'm going to discuss it just a little bit, and then you're going to tell me what the correct answer is. It says an airplane's altitude in feet during descent for landing can be found using the function f of x equals -300x plus 30,000. where x represents the horizontal distance in miles where the plane begins its descent. After new government regulations became law, the airplane's descent was modeled by this function now. So notice that it said f of x and now it says g of x. It's because there is a new function, a new line. It says -300x plus 30,500. Which statement describes this change? So before I start, this is technically going to be linear. If you've ever seen a plane descend, it goes down. Well, let me do it this way. Sorry, my selfie mode is tripping me out. Okay, this way is a descent of a plane, right? So it's going to start up high and then it's going to go down. This is telling us, and it's going down 300, I don't know, feet per whatever, I don't know. But that is how much it's going down as the slope. And it's negative because it makes sense. It is descending. Okay, it's going down. What I do notice, however, is the only thing that changed is this Y-intercept here. This 30,000 became 30,500. So think about a plane and what it's doing. So it's going to start in the air and then it's going to descend, okay? There is something that is happening to these functions that it changed from 30,000 to 30,500. And so we're going to figure out what that y-intercept would have been. It says the plane starts at, so we're figuring out which is describing the change. Remember, because this went from 30,000 to now 30,500. It says the plane starts its descent from an altitude 500 feet higher, or it starts its altitude descent from an altitude 500 feet lower. H and J are talking about the slope. It says the airplane descends 500 feet per mile faster or 500 feet per mile slower. This right here is talking about the slope, how fast the plane is descending. In both of our functions, it's descending 300 whatever, I don't know, but it's descending 300. So these are wrong because the slope is not changing. The thing that is changing is the y-intercept, or the starting point. So you tell me what happened. Was it starting 500 feet higher in this one or 500 feet lower in this one? All right, moving on to question number 3. This one says, what is the solution to a system of equations below? So it is only asking for the x solution. So if you are virtual, you will be graphing these in the form of ax plus by equals c, finding their crossing point and giving me the x value of that crossing point. You will probably need some paper to do this on. Just a quick sketch will work. If you do not have a quick sketch, you can go to this thing called Google Keep. You find it here. Let me just show you guys real quick. If you go to Google Keep down here, you can start new, it says take a note. You can start taking the note by drawing something. Go to open up and it lets you draw anything. So if you don't have paper, you can draw on here. You can use your mouse to kind of click and draw, right? You also have an option to use squares. So this is now a grid. You can make a graph. So if you needed to make the y and the x axis, that is how you do that, okay? And then you can kind of graph from there. Sounds good? So if you ever wanted to use this for anything else, you can also use rulers or notes or whatever. If you ever wanted to use Google Keep for actual notes, you could, I don't need that to be there, so I guess I'm just going to delete that note. You can actually make a note by like typing and stuff, okay? So it's pretty nice. Anyways, back to what I was saying over here. These are written in ax plus by equals c. For those of you in algebra class face-to-face, you can use the calculator to solve this using LinSolve. Menu 3.2, it is a systems of equations solver. Remember, you type the first function in the first box, the second one in the second box, and then that's it. You press enter. If you're having trouble with LinSolve, please ask someone around you. Ask a friend. It's not that hard to. It's easy to get this wrong, but it's not that hard to ask somebody for help. Okay. And then last question, number 4. This one's going to go pretty quick because I need you to know that this zero, the word zero right here is something that's important. It says, what is the zero of the linear function? So in a second, we're going to talk about zeros of quadratic functions. I need you to know that zero, the word zero just means what is the x-intercept. So even whenever we talk about the zero in the quadratic functions here in a second in our notes, you're going to be basically finding the x-intercept, which is the 0. So I'm not finding the y-intercept here. That would be 5. I need to go find the x-intercept. Tell me one number that goes or that the line passes through on the x-axis, and that is your answer. That is the x-intercept, all right? So you have 4 questions to answer to me today, and then you'll answer 4 of them tomorrow, and then we will be done for the week. So now that I am done with the warm-up, I am going to go to our notes really quick. We have some, let me see if I can move this. All right. We have some notes. I opened up a Google Keep so that I could write down some notes in front of you. I'm getting better at my pen, guys, but still not that great. All right, so some of you in-person kids might already know this, except it's a nice little refresher for you for what we're going to do today. Okay, so a quadratic function is a little bit different than just linear function. It's not a line anymore. It's a U-shaped graph, which we call parabolas. Parabolas. Funny word, but that's what we call them. You will always see an x squared when you're talking about quadratic functions, okay? Anytime an equation or a function has an x squared in it, a squared anything, as long as it's squared, it is a quadratic function, okay? It's not a linear function anymore once it says x squared. A quadratic function has some characteristics. First of all, if you actually graphed y equals x squared, the graph would look like this. It would have the starting place at the origin, 1 squared. So if I went to 1 on the x-axis, 1 squared is 1, so that means my point would be 1, 1. If I did 2, if I was trying to figure out where my point would go for an x value of 2, I would say 2 squared is 4. So that means my coordinate would be 2, 4. So I went to 2. That's not 4, that's 3. So I meant to do a point right there. Goodness, I have been messing up quite a lot lately. A point there. Oh, what is happening? Sorry. Okay, we're gonna pretend like none of that just happened and erase it. I hope. Okay, listen. Oh, eraser. You know what? Uh, okay, I'm gonna start over. Hi everyone, this is Quadratic Function Notes. I'm just joking. Okay, let me see if I can put. Okay, I'm still on eraser. That is my y-axis, and this is my new coordinate because I just figured out that my calculations were incorrect for my point at 2. It's always going to make a U, and I know as much as you want to make it into a V, it is not a V. It is a U-shaped graph. A V-shaped graph is something different. You will learn in Algebra 2. But this is a quadratic function. So quadratic functions have a few different aspects, features, characteristics, whatever you want to call them, about a quadratic function. First of all, zeros. Zeros, we just figured out, are x-intercepts. Zeros that are x-intercepts, over here we have 1. Technically, this graph was supposed to cross right or go through right there at the origin. This x-intercept is 0. However, sometimes we might have quadratic functions that go through the x-axis twice. We would have 2 zeros. Zeros are found by, remember those factors that we were finding not too long ago, where we would have binomials that looked like this, and we'd have some stuff inside of them like x minus 4, x plus 2, or something like that. Those are technically used to find the zeros. So we'll work on that a little bit later, which we have already done, but we're just like as a refresher, we'll work on that. And then there are some instances every now and then where the U-shaped graph will never touch the x-axis. Remember that the parabolas can also go upside down if it was a negative x squared, just so you know. If it's a negative x squared, it goes down like that. Doesn't matter. Don't know where, but as long as it's an x squared, it shapes down. Okay. So that one would have no zeros, none. Okay. Now let's talk about the y-intercept. Y-intercept is the same old, same old. It is where it crosses the y-axis. It's only going to cross the y-axis once because That's how quadratic functions work, but it's always going to cross the y-axis. Well, yeah, eventually. Even if it's really far away, eventually it would cross the y-axis because these lines go out like this forever and ever and out like that forever and ever. So the vertex of a quadratic function would be the very corner, or I guess you would call it a corner, basically the vertice of a quadratic function. So no matter which way it was pointing, even if it was over here way to the side, this is still the vertex. And then we start calling them some names, like this vertex right here is a minimum value. This vertex right here is a maximum value. And this vertex is also a minimum. It's a minimum because it is the lowest point of the graph. If this minimum just so happened to fall at 2, the number 2, would be the minimum value of the graph. That means the lowest value of the graph. If this was the minimum value and it was like -3, that's what would happen. If this value right here was, I guess, 1, let's say it was 1, then 1 is the maximum value of the graph. Okay, so you have minimums and maximums. We have already started to find vertices, I never know, through the actual formula called vertex form, which we started working with yesterday. And then last but not least, the axis of symmetry is the line that goes directly through, directly through, let's try this again. The very middle, the very middle of the quadratic function. The correct formula for finding the axis of symmetry is -b over 2a. -b over 2a, okay? All right, so you won't have to do axis of symmetry today, but you will have to do the vertex, the y-intercept, the zeros, some minimum and maximum values today. So this is what's happening for your actual assignment. Now pay attention face-to-face, kids, because you might notice something. You're going to go to IXL, and you're going to have a IXL called Characteristics of Quadratic Functions, which is the graph. If you choose to go to the search bar and put HW8 into here to find this, just do that. What you're going to be doing is finding things like the vertex. So this is a vertex, and it is asking you to put it in a coordinate form. The vertex for this graph is way up here. It is -4, 8. So I'm going to type -4, 8. And this was me just finding the regular old coordinate for that point right there. Okay. All right. That was that. Now it's asking for the y-intercept. It doesn't matter where the graph is, somewhere it's going to cross the y-axis. This one just so happens to cross the y-axis way down there at -9. All right, let's see what this question is asking. Y-intercept again, which is right here at 0. This one is asking for the vertex, which is right here at the origin, 0, 0. And let's see what this one is asking. Ooh, the minimum value. So anytime you see the words minimum or maximum, it's still talking about the vertex. However, this time it's not asking for the coordinate of the vertex. It's just asking what is the smallest number that you have on this graph. The smallest number up and down that we have is this 1 right here. So the minimum value, it goes all the way down to 1 and then comes back up. -1. Darn. I knew that. I went too fast. Sorry, guys. Okay, vertex. Yeah, same old, same old, same old. Okay, let's go to something different. Axis of symmetry. There we go. This is the line right in the middle here. This one is an easy one. It is x equals 0. So anytime you have an axis of symmetry question, you actually give an equation. Do not give an axis of symmetry and say 0, enter. Doesn't work because that is a value, not an equation of a line. This is the equation of a line that goes straight up and down. That is the axis of symmetry of this graph, okay? All right, so face-to-face kids, you have already done this. We had an extra time during the day one day, and you were working on this IXL. If your score did not get up to a 100 on this one, you need to go back and work it. Yesterday's IXL, I asked you to get higher than a 60. At this point, I'm good with a 60 for yesterday's IXL. So that was this one right here for the axis of symmetry questions. As long as you get a 60 on this one, you're good. That is the one that looks like straight up axis of symmetry, okay? I'm going to use Caden Anderson as an example. 7 skills. All right, so this one right here, find the axis of symmetry. He got a 63, he's good to go. He's done with it, all right? This one down here, sorry, Kate Anderson. This one right here, everybody was doing this. This was from Tuesday. I need y'all to get those grades up. Okay, he is not the only one, I promise. It is like everybody. If you have questions with that one, please let me know because I can help you. Just email me, all right? Let's see. That one, this one right here is going to be, actually, you know what I'm not going to do is I'm not going to gold star it. So I need everybody to know that you are going to find this IXL assignment, HW8. HW8 is characteristics of a quadratic function, graphs. Click it. You are working on this. Face-to-face, kiddos, you probably have already done this, and I can go check the grade in my system for your grade, okay? So you don't have to do it again. Use today as a makeup work day for yesterday's axis of symmetry, and the day before that's quadratic function vertex form, okay? Okay, y'all have a good day. See you tomorrow. Or not really see you tomorrow, but talk to you tomorrow. Yeah, that's working.